Alrighty, let's make sure this is recording. There we go. Yep, I think it's recording. Cool, yeah, let's start today's session. Um, Hi everyone, welcome back to this Python webinar. Today is the second day of this webinar, so if you haven't seen the first webinar, it is up on YouTube as a video. I'm pretty sure there is a link probably on our Facebook page, so if you hit that, it will take you to our first webinar, and you can quickly watch that when you have the chance. As I said before, today is the second day, and this is a Python course from scratch. So everything we will be teaching today is from complete beginners, and our main intention is to help people understand how to program in Python, and rather than just teaching them Python, helping them understand what they're doing and continuing on like that. So so if I share my screen, share desktop, display one, okay, cool. So let's move that away. There we go. So last webinar, we kind of went through what options are out there in order to program in Python. As I said last webinar, I would mainly be using Python's IDLE. And you can use other options. I will personally will be using this, and going forward, mainly this, and maybe Anaconda during later webinars. Now, last webinar, I did give people a challenge if they wanted to practice programming, which is on your screen now. So it was a simple program to make. All you have to do is write Python code that writes your initials like so. So if your initial was, like my initials are AS, you want to see an A made up of A's with a space, and then an S made up of S's. So I did make two versions of this program, reason being so a version that just does this normally, and I did give a challenge to people last webinar that this is possible to do in just one line. So I've made both versions, and I'll kind of explain both versions now. So I guess we could keep this to the side. Let's make this smaller. Let's just keep that there so people could read what the challenge was. So the first version is the more basic version, and the entire idea was to print out your initials like so. So my initials are AS. This is how my code looks like. The entire point of this exercise was to help you practice how to print out statements to the user. So remember, when you code in like this document here, and when you run your program, the entire point is to interact with users, interact with someone who's going to be using the program. And print is the simplest way of displaying text to your user. And this entire exercise, the entire point was to practice to play around with print. We did kind of discuss last session why we have these quotation marks, and we're going to get into that deeper today. But for now, this is the base version. This is kind of something, you should have something similar to this. So just line by line, printing what you want. So if I do run this, run module, you can see that it prints a S. It doesn't really matter how big the letters are. Point is, it just should look like an A or an S. The most basic version is to just have a set amount of characters that you can play around with. I had 5. So I had 2 characters here, and then 2 spaces here with an A in the middle, then a space here, A, space here, A, space here, then all A's or 5 A's, then an A, 1, 2, 3 spaces, and then another A, and same for that last one. Then just a print with nothing inside of it would just print an empty line, like it does over here. So that's I think that's one part of the criteria. Using same letter, draw out a blank line. Yep, a blank line should separate each of the initials. So that's how you just do a blank line, just an empty print statement. And then the S's are fairly straight. The S was fairly straightforward. Yeah, so that's the base version. If you completed this, well done. You should be fairly comfortable with print now, and the idea of print. So when you print something, it prints it out to the user. How many hours sessions? So this session would probably be. So by the way, I do have the chat up. So if you do send a message, I will be able to see. So I think the question was how many hours session. So this is daily, so we will be doing one every day. How long they are, it depends on what we're going through. But on average, it should be between 40 minutes to an hour max, probably. The reason being it's an hour max is average like retention span doesn't last longer than an hour. So anything more than an hour is probably useless to teach because you're probably not concentrating as well as you would like at the beginning of a session. So hour, probably 1 hour, probably maximum, and minimum around 40 to 45 minutes. So yeah, last session we did look at print. Now you should be fairly comfortable with print. Now the challenge version. So if I bring out the other version, here it is. This version is how many days? So that's a good question. So how the another question popped up is how many days probably as this course would be. This course I'm not entirely sure, but at least 20 or 30 days. Um, that being said, I intend to go through all of like basics Python, which is procedural programming, and however long it takes, and for people to understand. And then we'll get into object-oriented programming with Python. And we'll play around with objects at that point. So how long? I'm not entirely sure. These will always be as videos up online on YouTube. So if you do miss any later on, you could always just catch up by watching the videos on YouTube. They should be on our SB Components YouTube page, or there should be a link on our Facebook to the YouTube videos. Cool. So the challenge version was to do this exact program by in one line. So if I do run this for you, run module, as you can see, it gives the exact same output. You could also see that it is this program, challenge.py. And let's kind of get into how this works. So the entire idea for this challenge was to get, if you did do it, to get you used to Googling it. Unless you have done programming before, this would be fairly difficult. If you have done programming before, this shouldn't be too hard. But if you haven't, the entire idea was getting used to Googling how to do something and finding your answer like that. So the way this works is with something called string manipulation. So you basically, so the entire idea is this is a string. This entire, what I've highlighted right now is a string. Let's unhighlight that. This entire thing here is a string. String is a data type, and just like numbers and other stuff we'll look at today, you can manipulate strings. Now, in I think most programming languages, I can't think of one off the top of my head right now. In most programming languages, a backslash, then an n, basically means go to a new line, print to a new line. So the answer to the one-line challenge is to do this program in one line rather than having how many print statements this is. Rather than having 13 print statements, in order to do it in one line, you just use backslash n's. Now the reason this works is I believe in like common English, it's highly unlikely you have a backslash n. Don't get it confused with /n. This will not work with /n. So if I show you quickly, let's change this initial one instead of backslash n to /n. So by /n I mean the slash is pointing forwards. Backslash means the slash is pointing backwards. Obviously, this direction being forwards, this direction being backwards. So if you run this now, run module, wants to save it. As you can see, this doesn't work. It will print out /n because /n is, you probably will come up somewhere if you're writing text. On the other hand, backslashes in most programming languages are used as key features or keywords. So with strings, there are a lot more things you could do. The percent sign in, so the percentage sign in some certain scenarios is used as a key word or a key indicator in Python. So let's run this again, run module. Okay, there we go, it's all fixed. So I don't off the top of my head remember what percent does in certain scenarios. I just saw a message, is it a way, one way to add multiple strings? Yeah, we'll get to that in a second, how to add multiple strings. We'll get to that in a second. That's a good question. Just hold on. So the way to do the one-line challenge was just to literally add the \n where you needed to go to a new line. Do keep in mind, if we did add a space after this, it would print a space over here. So if we run module, as you can see now, this is slightly off because we added a space over here. So \n is literally exactly where you want your new line. So if we run this now, it should all be fixed. Yep, all fixed. Looks all fine. So that's how we do \n. \n just goes to a new line. It legitimately means just new line. So that's how you could have done this challenge in just one line. That's also the beauty about programming. Now that I mention it, you could do the same program in God knows how many different ways. I remember when I was first learning Java, I had to do pretty much the same program, and I did it in a completely different way. I could have recreated it in Python, but it would be less efficient, to say the least. So that's the beauty of programming. It could be done in hundreds of different ways. And as a beginner, it doesn't really matter which way you do, and the point is to get it up and running. So that being said, those were my two ways of doing it. If your way is different to this, but still prints out your initials in some sort of way that you could recognize it's an A or an S, it's perfectly fine. It's a perfect valid way of doing it. Just be aware that the beauty of programming is that it could be done in so many different ways. And that's also its curse. The fact that it can be done in so many different ways means when you sit down to look at someone else's code, it's a nightmare. If you don't think the same way as another person thinks, that's pretty much game over, unless the other person uses comments, but we'll get into that later. So so that's also its curse. So not being able to read someone else's code would be a problem if you go into the industry and someone says, oh, well, improve on this code. You won't be able to, because obviously they don't think the same way as you. But after a certain point, you could just work on any piece of code. But that just comes with practice. So that was the answer to yesterday's webinar's challenge. Today's webinar, we won't be looking at programming specifically. We will towards the end, and to kind of answer the question, how can we add strings? We will get into that towards the end, but today the main focus is to help you to understand. Does the whiteboard want to show up? There we go. To help you to understand data types in pretty much all programming languages. Now, first things first, what do I mean by data type? Let's move this to the bottom, actually. Let's move this here. I don't know if you can see these things, but yep, let's move them out of the way. Cool. So what do we mean by data type? So data types in pretty much any programming language is different forms data could be in. So we've been exposed to pencil, does it want, there we go. How do I, this is rubber, there we go. Cool. So we've been introduced to the first version, which is, there we go. We've been introduced to the first version, which is a string. Okay, this doesn't want to work. Let's, on the second hand, I was prepared this time because I thought I fixed it from yesterday, but clearly I didn't. Let's move back to this and let's just Google a whiteboard really quickly. Online whiteboard online. just so I could write and help you guys understand. Cool. So here is our whiteboard. I do have a graphics tablet, and for some reason, when I try to use a graphics tablet with this, with the tools the webinar provides, it doesn't really work. So let's get rid of the ad. Okay, about cookies. Cool. Give me 1 second. Cool. There was just a computer ringing in the background. Cool. Let's get into the meter today. Can you hear now? Is my mic working? Hello? Can you hear me? Should be able to hear me. Okay, cool. I can be here. Okay, so I just think one person can't hear me. Cool. So the meter today is just understanding different data types in programming languages, and therefore in tomorrow's session we would look at how to play around with these data types in Python so we could make better. For now it is a free course. Obviously I have the chat up. For now it is a free course, but maybe later on it may be paid. So if you do miss anything, there will these webinars will be uploaded as YouTube videos on YouTube. It'll probably be under our SB Components YouTube channel. There should be a link on Facebook. How many days are free? I am not entirely sure yet, but we will. It probably won't be paid for a while. So for now, it should be free. So don't worry too much about that. And plus, they're on YouTube, so YouTube is free for the most part. Yeah, so the block of today is understanding data types. I don't know how many times I've said that, but let's get into it now. Now that I probably have a working whiteboard, so we have been introduced to the first version of data types, which are strings. So by the way, this is for like complete beginners. If you're new to programming at all, we're going to try to help you understand programming and specifically Python, but it will give you tips about other programming languages, just so if you do need to apply your skills elsewhere, it wouldn't be too difficult. So the first thing we have looked at are strings, and the most obvious way to see strings or understand strings in a programming language is anywhere where there are quotation marks. So if we have quotation marks around anything, so like, I don't know, the $sign, and then someone's name, AMRIT, quotation marks around them means it's a string, and all a string means is a collection of characters. Strings could be technically infinitely long, as there is a limit, but you'll probably never reach the limit just because nowadays computers are really powerful. And we have a lot of memory nowadays, so technically speaking, you'll never reach this upper limit, but there is a physical limit to how big strings could be. Don't worry too much about it. You would probably never hit that limit. Other things will probably happen before you do hit that limit. But strings are the first version of data types we've seen. So strings is just a collection of characters. Do note that if there is a number within these quotation marks, let's say 1024, this is a string and not a number. This is very important to things we will look at tomorrow, especially how to play around with strings and numbers. But do note that this is a string, not a number. Python and most programming languages would treat this as a string, and you won't be able to add this to other numbers, essentially. The next thing we're going to quickly discuss are integers, or for short, int. In most programming languages, integers are just numbers, and whole numbers specifically. Whole numbers, and they could be negative numbers too. So anything from, I'm going to quote unquote say, I shouldn't use quotes, just quote unquote say that it could be technically from minus, that's not infinity. Where's the rubber? Let's rub all this out. So technically speaking, numbers can be from, ints can be from minus infinity to positive infinity. This is technically wrong. There is a lower limit and upper limit to what number you could use. But I doubt you would be using numbers that big, so you don't have to worry too much about that. So technically speaking, just for now, to understand, integers are just whole numbers between negative and positive infinity. So just as small of a number as you could think of and as big of a number you could think of. Do note this is technically wrong. There is a limit. There is a quick and easy test in Java to show you these limits. If I do get Java on this computer up and running, I may show you that later, just as a demonstration. But this is a Python course, so we don't have to worry about that too much. The next data type we're going to talk about, just before we get into the more obscure ones, is char or characters. Now, characters and strings are pretty much related. Characters use single quotation marks, and they can only hold one character. So a uppercase A or a lowercase a or a $sign. So characters are just like strings, but the only difference is one way to differentiate them is they don't use double quotation marks, they use single, and they only hold one character. Does means that it's same like, okay, I did get a question and I don't understand the first half. So does that means the same like, do we need char in Python? So char in Python does exist. So strings are the main things in Python. Chars I do believe they do exist in Python, but we won't be looking at them. This is just for you to understand that they are a thing in other programming languages. And in Python, they do somewhat exist, not to a whole extent, because Python does kind of help you out in that type of sense. That being said, chars do exist. This is mainly for you to understand that this is something that exists, and just for your understanding. So the main difference between char and string is that string is a collection, char is just one single individual character. I'm not going to dive too deep into this, but there is another concept of primitive data types, and char and int are both primitive data types. This basically means that they're the most basic data types. You can't really boil them down any further than that. Ints and chars are some of, I think Boolean are also primitive. These are primitive data types in the sense that you can't really boil down numbers anymore. You can't split up one character any further. So all a string is, in pure computer science like definition, is a collection of characters. That's what a string is. String is just multiple characters stuck together. Can we define something like ABC? It will be a char or a string. So in Python, Python doesn't really care if you do A, B, C. Python wouldn't care, but in other programming languages, they will give you an error, because this is supposed to represent characters, and you're technically only supposed to be able to use one character at a time. If you want to do multiple characters, you then need double quotation marks for strings. So Python, we could test it out. We'll test it out in a bit. The only way you will learn is by testing, making mistakes, and learning from those mistakes. So so Python wouldn't really care if you do that. I don't think it shouldn't care. Python does give a lot of leeway. But in other programming languages like Java, especially C, I think, C is, C, if from my limited exposure to it, does have characters and does enforce them pretty strictly. Java does too. I can't think of an example where Java will allow this, but there probably is some example. But that being said, Python shouldn't really care, but other programming languages would. So do keep that in mind. Characters should only be one character. The user characters is that later on you could then use their ASCII or Unicode value to do some sort of operation. This does help with stuff like encryption and all that type of stuff, but we don't need to know too much about Unicode or ASCII. All Unicoded ASCII is, it's every character's numerical representation. So if we scroll down, let's zoom out. Let's zoom out and that's not. How do I move? Nope. What's this? Very cool. Let's just right to the side here. Yeah. So characters, you're able to, because you're only using one single character, or you're supposed to only be using one single character, you can then use the Unicode or ASCII values in order to do some sort of calculation. All Unicode and ASCII is different ways computers use to represent characters or information. So I can't remember any values off the top of my head, but just as a really crude example, you have to understand that computers work on zeros and ones, binary. So all computers see. Whoops, let's change that back to a pen. All computers sees are zeros and ones. So something like that. That's what a computer understands. Computers don't understand a, b, char, int, string. Computers don't understand that. They only understand zeros and ones. And one way we translate these zeros and ones to something we could understand as humans is by having some sort of like translation table. If we quickly search up ASCII is the older version, but is still used in America and Europe. ASCII table images. If we quickly search it up, this table basically tells us what number translates to what character. So if you want a capital A in binary, you need the 65 number equivalent in order to represent that A. Now with characters, using chars, you could then do that conversion, and most programming languages allow that. I know Java does, and I've used characters in that sense to get the Unicode value. Unicode or ASCII. ASCII is an older version. As you can see, there's only 127 characters that ASCII allows. Reason being it's older because this is only the English alphabet. If you wanted to now, let's say, represent Chinese, Japanese, Korean, any other language, you need a lot more values, different architecture. So ASCII is the old version, which was used by Western, anyone who really spoke English, and hence it is the older version. But the point of all this is characters. That's one advantage that I could think of off the top of my head for characters. But the point is, you need to be able to understand that these concepts exist, so string, int, characters, and in your mind, you should be able to play around with them just a little bit for now. I'm going to refresh this, hopefully that it, yep, it clears everything up. So far what we have looked at are strings, integers, and characters. So let's just make a side note of them. String, int, and characters. Now there are three more we need to look at just for this explanation, and I'm going to cover one and then cover the other two together because they are related. So the first thing we're going to look at are Booleans. Now, I believe that's how it's spelled. Booleans are the most simple, technically speaking, data type. It's really straightforward. Booleans could only be one of two values. Booleans could only be either true or false. They cannot be any other value. Now, depending on your programming language, they may want you to spell true, false in a particular way. Python wants you to spell true with a capital T and false with a capital F, and that's the only way Python understands that this is a Boolean value. I think in Java allows you to use a lowercase t for true and a lowercase f for false. But Python specifically wants you to use capital T, capital F, just so it recognizes that these are Boolean values. Boolean, I'm pretty sure, derived from someone's name. I can't remember his full name off the top of my head. But Booleans are really true in the sense that if something's true, you could do some piece of code. If something's false, you could do some piece of code. And we will be looking into Booleans probably in 2 or 3 webinars down the line when we start doing if statements and all that type of stuff. Now, Booleans we will also look at when we do loops, so while loops. Boolean values are used a lot then. But it's fairly straightforward just from a grammatical standpoint. Booleans, just think of it what the actual values are. True, false. You should have a rough understanding of what they mean. True, something that's correct, something that's right. False, something's wrong, something incorrect. And that's exactly what they translate to when it comes to programming. So when something's true, it's correct. When something's false, it's incorrect. And we'll get into actual examples in a second, but that's another. And this Boolean, I believe, is also another primitive data type. So literally in a computer, true could be 1, 0, false could be 0. So if something's 1 in some register in a computer somewhere, that means it's true. If there's a 0 in there, it's false. So computers understand Boolean really well, and it's pretty straightforward. It does limit, like, I can't think of something off the top of my head other than while loops where I've used Boolean values explicitly. But it's good to keep track of. So let's say you're making a video game. I just thought of an example off the top of my head. Let's say you're playing a video game, and in this video game you collect items along the way. Let's say later down the line you collect an item, some sort of sword. Let's say you, that's my really rough example of a sword. Let's say in this video game you collect weapons or whatnot, and there's a sword that you could collect. At the back end, programming end, you could just have a Boolean value of whatever the sword's name is, just sword, and you could have it set to true or false. So until the player collects it, it's false. As soon as they collect it, it turns to true, and all of a sudden this entire piece of code activates that allows them to do whatever the sword allows them to do. So that's just a really basic example of Boolean where you'll probably use it just to keep track of the states of things. If something's more complicated and you need more states, then probably Boolean isn't your best bet. But that's just a crude example, just so you understand what you could do with Booleans. Now what I'm going to try to do is let's actually rub out most of this except for the Boolean I've written. Let's just rub out this sword example. Now the other two data types I'm going to explain are a little more difficult to understand. And they don't really apply to Python as they do to other languages. Python kind of combines them into one. Other languages has them as two separate data structures, data types. So the next two we're going to talk about are floats and doubles. Now these two data types are fairly similar in understanding what they are, but they fundamentally are different with the way they work. So in Python, don't worry too much about it. Just understand what they are and how why they are two separate things. Python combines them into one. So when we do play around with them, you don't really have to worry too much about it. But it still doesn't hurt to understand what the difference between a float and a double is. I realized I've spelled float wrong. Let's rub that out quickly. There we go. Pen. There we go, float. So these are two data types in Python, not in Python, in other languages. Python kind of combines them. And note that before I said what an int is, it's a whole number. So 10, minus 20, any whole numbers. So just by that, you should kind of have figured out that floats and doubles are decimals. So an example for a float would be 0.2, 0.8, 0.32, stuff like that. Those are floats. Doubles are the same, but doubles are kind of more difficult to understand, and let's get into why. So both doubles and floats are supposed to represent decimal numbers. So any number with a decimal. The reason it's called a float is because in most programming languages, I am pretty sure all programming languages actually, not entirely sure about the C lineups, C# or anything, but floats, the decimal point could float in where it sits. So to understand the inherent difference between floats and doubles, we kind of need to understand how computers work when it comes to numbers. So earlier I did kind of mention that computers work in zeros and ones, and the same, obviously it always works in zeros and ones, and that's the inherent difference between floats and doubles. So let's say, just for simplistic sakes, that actually I'm pretty sure most computers probably use 16-bit floats. So all that means the computers use 16 digits to represent one float. So let's just do 16 on the line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 placeholders in order to represent one number. Now, I told you that computers work in zeros and ones. And based on that, I won't get into too much detail on binary and how the binary number system works, but computers could represent any decimal number in binary. It may just take more figures than it does with us. Now, what a float means is, what a float does is the decimal point could float around and be at different positions. So you could have a float there, you could have a decimal point there, you could have a decimal point there. Point is some portion of the number is a whole number, so some sort of int, and the rest of it is the decimal. So if we rub out this, and let's see if we could rub out these decimal points. So now immediately you should be able to see a slight problem by using this method of representing decimal numbers, numbers with decimal points. And the problem is, let's say you want to represent a really large number with a really large decimal section. Now, how decimals work in binary are different to the way you probably think of it. We don't need to get too much into that. But the inherent problem is, let's say you require this amount of data to represent the first part of a number. You now only have one bit left to represent the second part of the number. Now, that is a problem in most cases. Let's say you want, as I said earlier, you want to represent a number which is really big and has a decimal point in it. That may not be possible with floats. That's where doubles come into play, and all a double is a float with double the amount of space it has in order to store the number. So whereas floats have 16 bits, I'm pretty sure in most programming languages floats have 16 bits in order to represent a number. Doubles then have 32 bits. So they have 32 placeholders where they could that they could use in order to represent a number. And same with doubles, the decimal point could float around and be anywhere. If we were to go into more detail between the differences between floats and doubles, is floats are less precise and doubles are more precise. We don't need to worry too much about that. I can't think of anything you would probably need to do which kind of needs to take advantage of one or the other. But just know that floats are less precise, doubles are more precise. Reason being is how decimals work in binary. Just a really quick lesson. So in a normal number system, so in base 10, so when we use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we have 10 digits, 0 to 9. Those are our 10 digits, and we work in base 10. So each place here is going to be 10 to the 0, 10 to the 1, 10 to the 2. So if we have a number there, its value is 10 to the 0 times whatever this is. If we have a number here, it's 10 to the 1 times whatever number this is. Obviously, this is 41. We know this is 41. But the way maths works is this is 10 to the 1 times 4, 10 to the 0 times 1. And that's just how our number system works. Obviously, we know this is 341, but this is 10 to the 2 times 3 plus 10 to the 1 times 4 plus 10 to the 0 times 1. And it's no different in binary. Binary is base 2, and they only have 2 digits, 2 numbers, 0 and 1. And that's all they have to play around. And and you kind of have to understand, when you're making computers, this is all we have to play with, because there either is electricity there or there isn't. The switch is either on or off. It's either true or false. So computers only understand one or two things. And how we now have computers, just by that base concept, is just it should be amazing to if you think about it too much. Now, if we go back into it, so in obviously binary, this has a value of either 0 or 1. Let's just say 2 to the 0, 2 to the 1, 2 to the 4, 2 to no 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, and so on. So this is how we represent numbers in binary. It's just you keep adding like these digits in order to make whatever number you want. So let's say you want to make 1. Well, that's simple. It's just a 1 here, and then the rest of them are zeros. There we go. You have your 1. Let's say you want 5. So 5 is going to be 1 plus 4, which is 2 to the 2. 2 to the 2 is 4, so that's 1, 0. So 5 in binary is 1, 0, 1. That's 5 in binary. Now, you could play around with this, but the reason I'm telling you this is to kind of explain this precise thing. Now, the way numbers work in decimals is the exact same with us in our number system. Is this is 10 to the minus 1, and then 10 to the minus 2, 10 to the minus 3, 10 to the minus 4. That's the exact same thing in binary. So this is 2 to the minus 1, 2 to the minus 2, 2 to the minus 2 to the minus 3. Now, this doesn't really translate well to our number system. Reason being is 2 to the minus 1 is 0.5. 2 to the minus 2 is 2 to the minus 2 is 1 over 4, 0.25. 2 to the minus 3 is 1 over 8, so on and so forth. So decimals in binary doesn't really convert well to decimals in our number system, which is why floats are known to be less precise because in order to represent, and so obviously 0.5, computers have no problem representing them because it's fairly straightforward. But a lot of decimal numbers that we have, computers can't represent the same way because they have to add some sort of combination of these in order to get as close as they can to it. So floats are known to be less precise because obviously they have less digits to play with in order to get as close as possible, as close as they can to whatever number you want them to represent, whereas doubles have more than enough space to represent what as close as they can to whatever decimal number you want to represent. Now that was a very large sidetrack into explaining the difference between floats and doubles, but I think it's useful. Python is a really good language to know. A lot of employers are looking for it, but sometimes you may want to convert your skills to other programming languages, and it's just good to know the difference between floats and doubles and all these data types. So in total, we have 6 data types: strings, ints, characters, Boolean, floats, and doubles. In total, that's 6. And just knowing them is really good. Now we're going to try to understand how to play around with them, and that will be it for today. So it is 1:44, at least where I am, so we will continue for another 5 or 10 minutes or so, just so I could give you a base understanding on how we play around, and then tomorrow we will look at how to do this further in more detail, and we will be introducing a new concept. So what we will do now is leave this. So just kind of make a mental note of this, and we're going to open up Python. So I did get a question earlier as how to add up strings, and that's kind of what I'm going to answer now. So let's create a new file. Let's save this first and foremost. Documents, lessons. So let's save this as lesson 2. Coolio. Now, it is possible to add strings, and that may confuse you at first, but it's not that confusing. So the best way to understand how something works in a programming language is to test it out. And if we were to test it out, my test would be something like this. So let's say you want to test what happens when you add Amrit and Sing. Now I know what happens, but I want you to kind of think of when I run this code, what will be the output. So I'm going to give you a few seconds. So run module is going to ask me to save. So just think about what this will print out. Cool. I'm going to hit OK, and it printed out Amrit space Sing. The reason I purposely left a space is that was just by nature, just by habit at this point. But there we go. Amrit Sing as one continuous string. Now, when you can add strings in programming languages, that's a perfectly fine thing to do. All you do is take one string and physically put it right next to the other one. So literally just joining strings exactly where one ended, you start off the other one, which is why I just naturally just put in a space. It was just inherent to me, just so it looks better. And this S starts as soon as the space ends. So that's what happens when you add strings in programming languages. You can do that. It's perfectly fine to do that. Another thing you could do is instead of plus, you could use commas. Now, if you run this, run module, OK, it will put in the space for you. So as you could see, I took away the space. Now, using commas just inherently puts in the space for you. There are other things in way you could, like ways to manipulate strings. Pluses and commas are the only things we will be using at the top of my head. We won't dive too deep into formatting strings. It's not really relevant unless you're gonna be making some fancy text-based program. But manipulating strings and formatting strings are a thing in every programming language, and it doesn't hurt to kind of read up about if you ever want to find a way on how to print something. Like there is a way in Python to print it letter by letter. So like if I run this, actually cancel, that's not what I, if I run this, run module, when I hit enter, just keep a look over here. It prints it all in one go, just one fell swoop. Like bam, there we go, just printed it out. Now there is a way in Python to do it letter by letter or like 2 letters or whatever. But just you're gonna have to research about that. There is a way of doing it in pretty much every programming language. I'm not going to teach that here. That's not necessary to know. I'm just getting you through to a point where you could make programs in Python and understand them. So today's session has all been about data types, understanding data types, and tomorrow we'll be looking at a more detailed version on how to play around with them. Of course, you could also add numbers and numbers like strings. So 10 plus 20 times 4. Now I kind of want you to kind of figure out what the output is before I press enter. Kind of think to yourself, quickly do the math. This is why when you do a computer science course, they require a good understanding of math, because a lot of programming could be considered like mathematical. But before I hit run, I kind of want you to think what the output of this will be. Will it be 30 times 4, which is 120, or will it be 80 plus 10, which is 90? So do you think, so basically the question is, do you think Python uses BIDMAS or BODMAS or whatever you were taught, or does it just do it in the order you give it to? So just consider, and then there we go, 90. So programming languages do use BIDMAS, BODMAS. Just keep that in mind before you start doing anything. If you wanted 130 for whatever reason, you then have to go on and use brackets more. When you run this, okay, there we go. There's your 120. So programming languages do use BIDMAS, BODMAS. I remember like growing up, there were 2 different versions that I was kind of taught. But point is, yeah, programming languages do use BIDMAS. So do keep that in mind. Are we recording? Yeah, we are. Cool. Programming languages do use BIDMAS, and it is very important to know once you start playing around with numbers. That being said, that is pretty much all the time for today. Thank you for so much for watching. Tomorrow's webinar is going to be, there is no challenge for today, so I'll only be giving you challenge after each milestone. The next challenge will be tomorrow. Tomorrow we're going to look at how to get data from the user and kind of process it, and how to convert from strings to integers to booleans, floats, whatever. We will be looking at that tomorrow. That being said, there is nothing else on my mind that I need to say. Just the only way you're going to get better at programming is by practice and playing around with it. So if you wonder, well, what will happen when I do this, just go and test it out. So I do kind of remember that someone asked for characters. So let's test it out. I told you Python doesn't really care. If we run this, it will print out ASDF, ASDF. Python doesn't really care about characters. Other programming languages do. So do know that in Python you can use one quote. It will treat it as a string. And do also know that 2 quotes will overpower one quote. So if you do use a certain type of quote, be sure to make it consistent and not be changing between them. I will not be giving notes because, well, I don't really have many notes prepared. Okay, so as it comes to notes, the only way I'm mainly here to help you understand programming. This will be a video afterwards. So if you want to make notes, you could just wait until it's uploaded on YouTube, then make notes off of that. That being said, that's probably the best way to make notes. But this is computer science. So I'm currently doing a course at university in computer science. And we don't have textbooks. We don't have textbooks because everything about computer science is online. If you ever want to search something up, if you ever want to know something about computer science, just Google it and the answer will be there. Like, I don't know, I'm currently doing internet protocol, so like, what is a DNS? Press enter, there we go, there's your answer. Everything with computer science is online, which is why on our course, in my course at least, we don't have any textbooks. So when it comes to notes, if you really want to make notes, this will be a video afterwards. But the best way to get better at computer science is by practicing. And if you can, teach it to someone else. If you could, the best way to learn is to teach. And if you could teach something to someone else, that's just going to increase your learning even better, because people start asking you questions that kind of push your understanding. I've been coding for, I don't know how long, for a very long time, so which is why I have answers to a lot of things people ask. That being said, if you have any other questions, let me know in chat now. Otherwise, this is pretty much done. Tomorrow there will be a challenge in tomorrow's webinar. At the end, I will give you a programming challenge that you could go away and try to do. And in the following webinar, I'll kind of give you my answer and walk you through how I did it. Do note, my answer will probably be different to yours. I've been programming for a while, so my answer would be fairly straightforward in how to do it. So just relax for today. Tomorrow's webinar, there will be a challenge. And it will be a difficult challenge, I will tell you that now. Next session will be tomorrow. These sessions are daily at 1 o'clock UK time. So this is, so tomorrow's session, as I said, just a quick overview. What we will be doing tomorrow is how to take input from the data and how to process it. So do know, I did say in yesterday's webinar that, no, I don't think I've said this. No, I'll say this in tomorrow's webinar then. This is pretty much almost an hour now anyway. So how to access recorded video. So these recorded videos will be on YouTube. We will, as soon as they're up on YouTube, we will post it on our Facebook page, the link to the YouTube video, or you could search up SB Components on YouTube. Just keep an eye on our Facebook page, SB Components, and as soon as it's on YouTube, we will send a link there. Let me also put the chat in the middle here now. We have no use for these. Cool. So I do see the chat. Cool. So any other questions? I'll wait another minute. Otherwise, thank you everyone so much for watching. Tomorrow we will be looking at, it will be a bigger step towards being able to create more complicated programs. Yesterday was the main thing of displaying information. Tomorrow's session is going to be taking information and doing something with that information. So I'm going to be here for another minute or so. If you have any questions, be sure to let me know, and I will see you then in tomorrow's session. I'll be here for another 30 seconds or so, so if you do have a question, let me know. But if you do want access to the recorded videos, they will be on YouTube. Just keep an eye on our Facebook page. We will probably post a link to it there, or you could search up SB Components on YouTube and it should be there. Cool, so looks like no one has any questions, so thank you everyone so much for watching, and I will see you in tomorrow's webinar. Bye-bye.